Imagine your grandmother hands you a photograph. "This was taken the day the Earth was born," she says, entirely straight-faced while offering you a biscuit. You politely nod, assuming she's having one of her moments. But then, plot twist, you look at the photo and the people in it are wearing clothes from a century before the Earth existed. That is essentially what the James Webb Space Telescope has done to cosmologists. It has handed humanity a photograph, and the people in it, ancient galaxies, fully formed and strutting about, should not exist yet. The universe wasn't even dressed at that point, and yet, there they are, smiling, waving, completely unbothered. Welcome to one of the greatest ongoing crises in the history of science. Grab a seat. This is going to get wonderfully weird. So, what did Webb actually find? In a recently published scientific study, researchers announced that the Webb telescope captured images of extremely early cosmic objects dating back to roughly 120 million years after the Big Bang. Astronomers admitted that seeing structures this early was not what they predicted. While we know the universe is incredibly ancient, it certainly isn't infinitely old, at least according to current models. Let's pause and think about this. When the Webb telescope peers as far into space as possible, it can observe objects up to around 46.5 billion light-years away. This distance defines what scientists call the Hubble radius, also known as the Hubble sphere. Interestingly, the most distant galaxies detected by the James Webb telescope are still located within this region. Originally, the farthest galaxy observed by Webb was known as Maisie's galaxy, believed to exist roughly 450 million years after the Big Bang. That record was later surpassed by another galaxy called MOM-Z14, estimated to have existed about 280 million years after the Big Bang. We've discussed this one multiple times before, so no need to put you through another cosmic lecture. Your brain deserves mercy. What we do know is that the universe is expanding. And as space stretches outward, this Hubble region grows larger, gradually allowing light from previously unreachable objects to drift into view, like distant fireworks finally becoming visible after a delay. But here's where things become genuinely fascinating and slightly unsettling. The universe isn't just expanding, it's expanding faster and faster. Beyond the edge of the Hubble sphere, space itself stretches faster than light can travel. Because of this accelerating expansion, the Hubble region won't keep growing forever. When we observe extremely distant objects beyond this boundary, their light is essentially racing toward us. However, the expansion of space between us and those objects is so rapid that the light can't catch up. It's like trying to run toward a finish line that's sliding away faster than you can sprint. Exhausting, frustrating, and ultimately impossible. This leads scientists to believe that the Hubble sphere will eventually stop expanding once it reaches a final boundary called the cosmic horizon. This region defines what we refer to as the observable universe, an enormous spherical region roughly 93 billion light-years across. Think of it as the ultimate cosmic viewing bubble. Everything inside it can, in theory, be seen. Everything outside it remains forever hidden. Not because it's invisible, but because its light simply hasn't had enough time to reach us. Light from objects inside this sphere has been traveling for billions of years to arrive at our telescopes. Anything beyond this region remains permanently out of reach. Even the most advanced telescope humanity could ever dream of building wouldn't be able to capture that light, because it just hasn't arrived yet. Naturally, this raises a mind-bending question. How large is the universe beyond the limits of what we can observe? The honest answer is, we don't really know. Scientists have mathematical estimates, but certainty is still out of reach. Some models suggest the universe could be finite, but unbelievably vast. Others hint that it may stretch on forever without end, which, if true, is the kind of idea that makes your brain feel like it needs a reboot. Certain studies suggest that the full universe may be at least 250 times larger than the observable universe. Some theoretical estimates go even further, proposing sizes that involve numbers so large they look like someone smashed their keyboard in frustration, powers stacked on top of powers until counting them becomes meaningless. Despite the overwhelming scale, observations show that matter appears evenly distributed throughout the universe. Temperature measurements of the cosmic microwave background radiation also appear remarkably uniform in every direction. These clues suggest the universe might actually be infinite in size, a possibility that's both thrilling and slightly terrifying. One of the most amazing aspects of studying distant space is that observing faraway objects is essentially the same as looking backward in time. The most distant galaxies we see near the edge of the Hubble sphere are not snapshots of the universe today. Instead, they reveal how galaxies looked billions of years ago. In other words, telescopes don't just show us space, they show us history. According to the widely accepted cosmological model, roughly 14 billion years ago, everything within the observable universe, and possibly even beyond, was compressed into an incredibly tiny state known as a singularity. If the universe is finite, this explanation works quite well. However, if the universe is truly infinite, which some evidence seems to support, then it may never have been confined to a single point at all. If that idea turns out to be correct, the Big Bang wouldn't have happened at one specific location. Instead, it would have occurred everywhere at once. That would mean the first galaxies didn't form in one isolated corner, but emerged throughout the entire universe simultaneously, including regions far beyond our ability to observe. From this viewpoint, matter may have appeared everywhere at nearly the same moment. The cosmic microwave background radiation detected from all directions would represent the earliest light produced across the universe, like the faint afterglow of a cosmic sunrise. Rather than representing a single explosion from one point, the singularity could instead describe a state in which matter and energy emerged everywhere simultaneously about 13.8 billion years ago. Even though this explanation fits many observations in modern cosmology, new findings from the James Webb Space Telescope are starting to make scientists rethink certain assumptions about the universe's timeline. Each deep space image captured by Webb seems to deliver a surprise, and occasionally, a mild scientific panic attack. These unexpected discoveries are forcing astronomers to reconsider details of the widely accepted 13.8 billion year Big Bang framework. By late 2022, astronomers believed the most distant possible galaxy candidate was called Sears 93316, although it had not yet been confirmed. Later studies revealed that this object was actually closer than expected. Its extremely red appearance was caused by thick cosmic dust, which fooled observers into thinking it was farther away than it really was, a bit like mistaking a dusty window for a mysterious fog. More recently, however, the James Webb Space Telescope detected another remarkable galaxy candidate that once again caught scientists off guard. Researchers identified an object known as F200DB-045, believed to have an extremely high redshift of about Z equals 20.4. This corresponds to a time roughly 168 million years after the Big Bang. If confirmed, this object would rank among the earliest galaxies ever observed. For now, it remains a candidate and must undergo additional testing before scientists can celebrate, or panic, officially. Should the discovery prove accurate, researchers may need to adjust aspects of the standard cosmological model to better estimate the true age of the universe. A few months ago, the Webb telescope revealed yet another surprise: massive galaxies appearing astonishingly early in cosmic history. According to current models, galaxies that large shouldn't have formed so quickly. For that to happen, nearly all available gas would have needed to transform into stars with almost perfect efficiency, something scientists consider extremely unlikely. In fact, producing galaxies at such speed is so difficult that many researchers describe it as nearly impossible within existing models. To put this into perspective, our own Milky Way galaxy required billions of years to grow into its present size. Yet Webb has detected galaxies with comparable mass appearing only a short time after the Big Bang, which feels a bit like discovering a fully grown forest just days after planting seeds. Discoveries like these could dramatically reshape our understanding of how the first galaxies formed. In another remarkable observation made possible by Webb, a research team known as gawst detected something extraordinary in the early universe. Two black holes merging roughly 700 million years after the Big Bang. Using Webb's powerful infrared instruments, scientists were able to observe signals from this ancient cosmic collision. Researchers believe frequent black hole mergers may have helped black holes grow rapidly during the universe's early stages, basically cosmic heavyweights bulking up at record speed. Taken together, these discoveries raise intriguing questions. Some scientists suggest they may indicate the universe is older than previously estimated, or perhaps that it never had a single beginning at all. If the universe truly extends infinitely, it's reasonable to wonder whether its age might also stretch infinitely into the past. From this perspective, what we call the Big Bang might not represent the absolute beginning of existence. Instead, it could mark a major transition within an already existing cosmic system, more like the start of a new chapter rather than the first page of the book. That said, these ideas remain speculative. Much more research is needed to determine whether an eternal universe without a clear starting point can fit within existing scientific theories while still explaining everything we observe today. And that's where things stand. Scientists staring into the deepest corners of space, scratching their heads, double-checking equations, and probably reaching for extra coffee. Now it's your turn. What do you think about this growing mystery in cosmology? Are we missing something big? Or just discovering how wonderfully complicated the universe truly is?